Hi, my name is Suman. I'm an assistant professor in SBST Maths department. So today I'm going to discuss about set and relation. Okay. So I will define what is a relation between two sets, and then via an example I will discuss why this definition makes sense. Okay, so before I will just briefly mention a very important binary operation on sets. So that is Cartesian product of two sets A and B. Okay. So the Cartesian product of two sets A and B is denoted as A cross B, and it is defined to be A comma B, the tuple where the first coordinate is coming from A and the second coordinate is coming from the set B. So one example would be if my set A consists of A, B, two elements, say A1 and A2, and B consists of B1 and B2, then A cross B contain A1, A2, A1, B1, B2. So A1, B1, A1, B2, A2, B1 and A2, B2. Okay, and it is to be noted that A cross B is not always same as B cross A. So it is not in general. Okay, so I just need this very important binary operation of between two sets. Okay, now I will define what is the relation between two sets. Okay. A relation between two sets A and B is a subset of A cross B. So this is the Cartesian product between A and B. Okay? Yeah. Now I will just give a example and discuss why this definition makes sense. Okay. So for example, I want to collect a data of heights of a particular group of students. So let's take S to be the set of all first year CAC students of SBIST. Okay, and I want to collect the heights of these students. So how will I collect that? So how will I write that data in a particular way such that everyone can understand? So say there is a student name called say Ankit. I will write Ankit, comma, say 177. In this way, suppose we give this data to anyone, he can easily understand that Ankit has height 177. Similarly, say there is a student named Ankur and his height is 187. I will give that data also, so the person, a layman can easily understand Ankur has the height 180. So like that, okay. So I will collect this kind of data. Now Ankit comma 170. So this element is a element of the set S cross R. I think it is very easy to understand because we define A cross B to be A comma B, where A, the first coordinate coming from the first set and second coordinate coming from the second set. Here Ankit is coming from S because Ankit is a student of CSC, first year student of CSC, and 170 is coming from the real number set, where I just briefly mentioned that R is the set of all real numbers. Okay. Okay. So similarly, Ankur comma 180 is also an element of S cross R. So that means, so this means the relation, the data of height of first year CSC student is giving a relation between the set S and real number, right? So this is, we can say this is height relation between the set S and R, and all these data are coming from where? So all these data are coming from there are lots of data, other data is coming from S cross R. So this is indeed a subset of S cross R. So in this way we get a relation between S and R, and that is a subset of S cross R. So that's why this definition makes sense, the relation between this definition. Okay. So now I am going to define some different types of relation and discuss some example. Okay. Yeah. First of all, let me define another example. So, yeah. Before that, I just mentioned that a relation between S and between a set S and itself is called a relation on S. So this is the notation. Okay. So relation between S and itself. So this relation is from S and S. So we do not write like that. So instead we just call it a relation on S. So let me give an example. So yeah, for that I need some notation. Notation, I just define notation. Okay. So suppose R is a relation between set A and B. So as the definition says that R is a subset of A cross B. Okay. So we can write like R as a set like that. Say A is and B contain B1 and B2. So suppose my R is A1, B1, A2, B2 and A1 B2. Okay, so that means, so notation says that if R contains this many elements, so that means A1 is related to B1, A2 is related to B2 and A1 is related to B1. So this is equivalent saying that A1 is related to B1. Okay, similarly A2 is related to B2 and A1 is related to B2. Okay, and also this A1 is related to B2 also denoted as, can be denoted as A1, the relation symbol A1 related to B1. This is A2 related to B2 and A1 related to. So instead of writing the whole sentence, we can write these symbols. Okay? Okay. Good. Now I will discuss an example. Yeah. So I will discuss a relation on a set. Okay? So let the set to be Z, which is the set of all integers. Okay? So we define a relation R on Z as follows. So A related to B, A and B both are coming from Z. If and only if A divides B. Okay? So in this example, one can see that 1 is related to 2. Why? Because 1 divides 2. Similarly, 2 related to 4 because 2 divides 4. Okay? So in other words, we can describe this relation in other way. We can write R as the set A comma B belongs to Z cross Z such that A divides B. So this definition of the relation and this definition is same. So these two definition of R is same, equivalent definition. Okay? So we define like A related to B if and only if A divides B. It is same as saying that R is the subset of Z cross Z, written like that. So A comma B if A divides B. Okay? Now I will discuss different types of relation. Okay? The first one is reflexive relation. Okay? So now from now on, we are letting that R is a set on a set S. Okay? So let R be a set on a set S. Okay? Reflexive relation. R is said to be reflexive if A related to A for all A belongs to the set. Yes. Okay? This is same as saying that R contains A comma A reflexive relation. Okay. Second is symmetric relation. Okay. Symmetric relation. The relation R is said to be symmetric if A related to B implies B related to A. Okay. In other sense, if I define it like in the set form, so it says if equivalent definition, if A comma B belongs to R, then B comma A also belongs to R. Okay. So this is the definition of symmetric relation. Next is transitive relation. R is said to be transitive if A related to B and B related to C implies A related to C. Okay. Equivalent definition, A comma B and B comma C belongs to R if then A comma C also belongs to R. Okay. So this is transitive relation. Next, the last one in this series. So anti-symmetric relation. Okay. Anti-symmetric relation. R is said to be anti-symmetric if A related to B and B related to A implies A equals to B. Okay. Equivalently, A comma B, if A comma B and B comma A both present in R, then A has to be equal to B. Okay. So these are some types of relation. So reflexive, symmetric, transitive and antisymmetric. I will just briefly mention the example I have given earlier. We will verify whether this condition satisfy for that relation or not. Okay. Okay. So our relation was A related to B. The set was what? Set was Z, the set of all integers. So A related to B if and only if A divides B. Now reflexivity. Why it is reflexive? Because it is reflexive. Because A related to A. Why? Because A divides A for all A. So this is A related to A for all A belongs to Z. That's why it is reflexive. Okay, so it is very easy. It is very easy. Okay, yeah. So one thing to be noted that our set cannot contain 0. Okay, because division by 0 is undefined, so that's why we remove this 0 element. Okay, nice. Okay, then symmetric. Why it is symmetric? Is it symmetric? Is it symmetric or not? Okay, so symmetric says, suppose A related to B, then B should be related to A. But here 1 related to 2. Why? Because 1 divides 2. But 2 does not divide 1. So that means 2 does not related to 1. So this R is not symmetric. Okay? It is not symmetric. Next, transitive. So transitive says what? So let A related to B and B related to C. So this implies A divides B and B divides C. This also means B equals to A into some K1 and C equals to B into some K2, where for some K1, K2 belongs to Z. Okay? So this implies C equals to what? A, so we replace B by A into K1. So K1, K2. So that means A divides C. So A related to C. So that means the relation is R is transitive. And the last one, antisymmetric. Verify whether it is antisymmetric or not. So let A related to B and B related to A. Okay? So this implies A divides B, also B divides A. When this is possible? Only when A equals to B. So that means R is antisymmetric. Okay? So we just proved that the relation we have defined on the set of integers is reflexive, transitive, antisymmetric but not symmetric.